yes, the infinite two-sum LeetCode problem. Basically, you're given an array and you have a target, which the sum is in the array only once. So here our target is 7. So, and 3 plus 4 is 7. So we want to send back the indices of 3 and 4, which is 0 and 1. Now, how would we do this? Well, at first you might think, all right, we'll put a for loop in here. Great. So we set I equals to 0, and we said j equals to 0. And here is our j, here is our I. We nest the j for loop inside of the I for loop. So at first, the j goes 1 by 1. 3 plus 3, 6. 3 plus 4, 7. 3 plus 2, 5. 3 plus 9, 12. And you can already see 3 plus 4, 7. Great, we return back the indices 0 and 1, and that's done. But actually, if our target was 6, right? For 6, we're going to need what? 2 and 4. Well, what's going to happen? Well, our j is going to start off here. It's going to check 3 plus 3, 6, and it's going to reply with our indices are 0 and 0. So you're going to say, okay, well, I'm going to add an AND loop. Check that the indices are the same. Check that the sum is the same, but the indices are different, right? Then what's going to happen is it's going to go 3 plus 3, and then it's going to say, okay, but both of them are 0, so it's not going to count. Then j becomes 1, j becomes 2, j becomes 3, and then it goes back to the start, and then our I becomes 1, so it's showing us 4. So again, we try 4 plus 3, 4 plus 4, 4 plus 2, 6, and then reply with this index. Well, another optimization we can do is instead of checking that they're equal, we start off j as always after I. So if I is 0, when we're initializing j, we start j at 1. This way, we never have this problem. And also, later on, if I is equal to, let's say, 3, we don't have to check j back from the beginning, all of these ones, we can just start it from 9. And this is around as optimized as we can get using the solution. However, there is a better way we can use it, which is O of n, which means, hey, attention, guys, don't zone out, which means O of n, which means only by going through the array once in one loop, we can find the answer. Well, like all problems in life, the answer is our dear old friend HashMap. A HashMap is a key and a value. So at the beginning, our HashMap book, and we're going to assume that looking at this HashMap book is instant. We can look at all of the values in one time, all right? If you're doing two-sum problem, it's a bit too complicated for you to understand how a HashMap really works. But keep in mind, whenever you have a HashMap and you want to check a value, it only takes one try. Just think about it like that, all right? So what we do is we set a single pointer instead. So pointer I, and we have a HashMap down here with the index and the value. Or actually, the key is going to be the value and index. So what we do is, well, our I is on 3. And it goes to the next one, 4, and it saves 3 with its index to our HashMap. And then it checks, in order to get 6, what would we need? We would need 4 plus 2. It checks the HashMap. Is there a 2 inside of the HashMap? No. Well, then it goes to 2, and it adds a 4 here. Again, for a 2, what do we need with a 2 to get 6? We would need a 4. We look inside of our HashMap. Yep, there's a 4 here. We return, yep, we have a 4. The index is 1. We know the index that the I is on already. It's just I. And we return that index, which is going to be 1 and 2.